Hi everyone, here is part 4 of lesson 3. Our last thing that we need to talk about is how do we divide, or another way, how do we rationalize the denominator with our radicals. Okay, let's look at e. So we have the 4th root of 80 over the 4th root of 5. Now, what we can do, especially if we see the numerator and denominator, if both of the values are underneath the radical and we know that, they are divisible, we can actually put this as one whole fraction. Here's what I mean. So I have the 4th root, and I'm going to have 80 divided by 5. Now, when I do 80 divided by 5, that actually gives me 16. Now, if you don't know your perfect fourths, that is all right. We can see if 16 is a perfect fourth by plugging it into our calculator. So let's go ahead and do that. So remember, we press the number 4. If you have a scientific calculator, press second in the caret key to get that x radical. If you're using the graphing, press math. We're going to go to number 5, and I'm going to plug 16. 16 is a perfect fourth, so it gives us 2. So here our answer is just 2. Okay, let's look at f. We have the 5 over cube root of 2. Now notice 5 is not underneath the cube root of 2, so we can't really put it together like we did with e. Now, we actually did something similar when we had to rationalize the denominator in our quadratics unit and we had square roots. Remember, the whole goal is to try to get rid of this radical. Now, when we did it with square roots, we just looked at what was in the denominator and then multiplied the top and bottom by that. Well, if we try to do that, especially with something other than a square root, let's say we do cube root of 2, right? Well, if we do 2 times 2, that would give us 4 in the denominator. Now, is 4 a perfect cube? No. So we can't necessarily just take what we see in the denominator and multiply the top and bottom by it. Instead, what we have to do is we need to multiply this denominator by something, so 2 times a number, to give us a perfect cube in the denominator. Now, we do want to pick the smallest perfect cube that 2 can go into. You can pick other ones, but that means you're going to have to simplify a lot more in the end. So we're trying to not simplify as much. Well, if we think about our perfect cubes, the smallest perfect cube that 2 can go into is 8. Now, once again, we can't just magically change this. We got to multiply. Well, 2 times what would give us 8? That's going to be 4. So I'm going to multiply the top and bottom is the cube root of 4. Okay. So that allows us in the denominator 2 times 4 to give us 8. Now notice here, I cannot do 5 times 4 to give me 20 in the top. The reason being is 5 is not underneath the cube root. So remember when we did our multiplication, that just means this 5 will go in front of the cube root of 4. Okay, because I can't multiply. So when I simplify this, we have 5 cube root of 4 in the numerator, that's 5 times, and then we take the cube root of 8, that gives me 2. Now my numbers on the outside of my cube root of 4, 5 and 2, I actually cannot simplify those numbers, so this would be my final answer. Okay, let's look at another one. I want you guys to pause the video and go ahead and try G and go ahead and try H. So go ahead and try both of those. Okay, here's your answers. So let's look at G. So once again, we have 7 over the cube root of 3. Now notice 7 is not underneath the cube root, so we can't simplify there. We need to rationalize the denominator and get rid of this cube root in the denominator. Now, what I'm thinking of is, what is the smallest perfect cube that 3 can go into? Well, that's 27. So you have to think, well, what can we multiply to get to 27? It's going to be 9. So I multiply by the cube root of 9. Now notice I have to have the cube root. I can't just do times 9, because since 3 is underneath that cube root, we can multiply 3 and 9. So be very careful. You definitely have to make sure you do that. Just multiplying it by 9, like you just did this, that would be wrong. You can't just multiply by 9. Okay, now in my numerator, notice that 7 is not underneath the cube root, so I can't do 7 times 9 to give me 63. All I can do is place 7 in front of that cube root of 9. We go ahead and simplify. The cube root of 27 gives us 3. And notice 7 over 3, well, those we can't simplify anymore, so here's our final answer. Okay, we do the same thing on H. So here we got the cube root of 4. We need to rationalize the denominator. I think, what is the smallest perfect cube that 4 can go into? It is 8. And so it can go into 8 twice. So I multiply the top and bottom by cube root of 2. Remember, not just 2, but cube root of 2. In my numerator, notice with my 8, since it's outside the radical, I can't do 8 times 2 to give me 16. All I can do is place it in front of the cube root of 2. We get cube root of 8 in the denominator, and I go ahead and simplify. So we get 8 cube root of 2 over 2. Now notice my numbers that are outside, 8 divided by 2, I can actually simplify that. So when I divide 8 and 2, that gives me 4, and I keep that cube root of 2. And so that would be my final answer. Okay, we have another one that we're going to try as well, so we can keep practicing with this. Okay, so we're going to do I together. We have the 5th root of 7 divided by 8. Now notice this whole fraction is underneath a radical. Well, when we do 7 divided by 8, that gives us a decimal, so that's not really going to help us out. What I'm actually going to do here is I'm going to separate. So what that means is I'm actually going to have the 5th root of 7 in the numerator and then 5th root of 8 in the denominator. Now, just like we've been doing, what we are trying to do is multiply the denominator by something to get a perfect fifth in our denominator. Now, we have to think, what is the smallest perfect fifth that 8 can go into? It is 32. Well, you have to think, well, 8 times what will give us this 32? We're going to multiply the top and bottom by the 5th root of 4. So remember, you can't just multiply the top and bottom by 4. This does not work. It has to have a 5th root around it in order to work here. Now, in my numerator, because 7 is underneath that 5th root, I can do 7 times 4 to give me 28. So I actually do have the 5th root of 28, and then 8 times 4, that gives us 32. Now let's think about our 28 here. We got to figure out if there's a perfect fit that goes into it. Well, really, other than 1, the next one would be 32. Well, 32 can't go into 28. So really in our numerator, we're left with 5th root of 28. And then we go ahead and do the 5th root of 32. That gives me 2. Since I can't simplify it anymore, this would be my final answer. Okay, that is the end of our lesson 3 notes. If you have any questions, make sure you email me or let me know, or come in before or after school during Tiger Time when I'm available. Okay, see you guys later.